Hello, my name is Adam Carricker. I am in ECE 561, and I would like to share with you my challenge assignment number 1. For this assignment, we are to develop a system using C language that will verify we can successfully erase and write to 128 kilobyte flash main memory locations once every minute. In doing this, we are to employ the watchdog timer, and this should be configured to reset the system every 1 second unless the software prevents the reset by clearing the watchdog timer counter. Our user interface must follow all these stipulations that every time the system successfully completes a write of all 128 kilobytes of these flash main memory locations, which would be every minute, a green LED should come on for about 1 second. If the watchdog timer ever times out and resets the system, a red LED should come on for 1 second. And the user should be able to press and hold the button in order to force the watchdog timer a timeout condition, otherwise the timeout condition should not occur. Alright, so here we are with the MSP432, and here is our code. Just to give you a side-by-side comparison. This is main.c in our challenge assignment 1, and here's the the header for the file. And so basically our code is set up into there's 3 functions. There's the interrupt surge routine for the watchdog timer, the switch 1 interrupt surge routine, and the main function. So in the main function, it's set up into 2 basic parts. There's the initializations, and there's the main while loop. And so the initializations basically just goes through and initializes everything we're using. And to do this, I'm using the driver library functions, and these are actually using the map prefix, which pulls them from ROM unless there's an updated version in Flash. So all of these functions are using the map prefix just so we can get the best of both worlds that way. So basically we're going to set the flash wait state to 2, set the digitally controlled clock oscillator to 2 megahertz, and we'll use that to set the master clock and main clock and sub-main clock. And those are both going to be set to about 32 kilohertz by dividing this by 64. We're going to initialize the red LED by setting it as an output pin, and set the output low on the pin. Then initialize the green LED same way, setting it as an output and setting it low for now just so the LED is off when we start the program. We're going to initialize switch 1. We're going to initialize it as an input pin with a pull up resistor, so we can use it as a switch behavior. And then we're going to create an interrupt surge routine and attach that to switch 1. So whenever switch 1 is pressed, it runs the interrupt service routine. So we're going to go ahead and register the interrupt, and basically we're telling it that we're going to have an interrupt on switch 1, and we're going to point it to the interrupt surge routine we created, which is up here, ISR switch 1, and I'll get to what this does in a little bit. So then we also clear the interrupt flag for that, so it's not set when we run the program. We enable the interrupt after we cleared the flag, so it doesn't automatically just go to the interrupt. And then we initialize a watchdog timer, basically to keep our system in check. And we set it to interval timer mode so that it actually does like the switch and throws an interrupt instead of just resetting the system. We set the clock iterations, we set the clock source to sub-main clock, which is actually the same configuration as main clock, and again this is at 32 K iterations, which will make it run about 1 second before it times out. And so then we also set the pointer to the ISR for the watchdog timer, and then start the watchdog timer down here. So let me just go back up to the interrupt service routines and show the logic behind those. Basically with the watchdog timer, all we're going to do is turn the red LED on when this is hit, wait 1 second, and then turn the red LED off, and then perform a soft system reset using the driver library reset control, initiate soft reset. As far as the switch 1 goes, what we want this to do is when we press switch 1 right here, we want switch 1 to basically not do anything and stall the processor. And so we have no operation. So this basically, we do not clear the flag for the interrupt so that it gets called again. So basically this does nothing, returns, it gets called again, does nothing, returns, because the flag is not reset. And we want to do that so that we can keep polling for interrupts, but still catch this until the watchdog timer interrupt flag occurs. And then we'll keep doing this until the watchdog timer expires, then it throws the flag for the watchdog timer. And since this has a higher precedence than this has a lower precedence, we'll go to this one, and then we'll reset the entire system. So that's basically the whole idea behind the code. And going down into the actual main while loop in main, we're going to keep looping indefinitely through this entire thing with this while one statement. And then we have 32 iterations basically. For 32 iterations, from I is equal to 0 to 32, we're going to do all of these things. And so basically we're going to erase and program each 4 kilobyte sector during this. And so we do memset to create the data we're going to program into memory. And I split this up into 2 parts, the buffer 1 and buffer 2, because I could not get the basically when I tried to make the entire 4096 memory location written to at once, it was too long for the watchdog timer and it timed out. So I split it up into 2 so that it would work with the watchdog timer. So then I set a new operation here. You can set a breakpoint to check memory before we unprotect and erase a flash. Then we unprotect memory, erase the flash, set a breakpoint again to see the flash after it's been erased, and then we program the first half of the memory, like I said, with the first buffer, only doing 2048, and then we do the clear timer. So we basically reset the watchdog timer so it doesn't time out on us, and then we do the second half with buffer 2 and the last 2048, so that in total it's 4096 or 1 kilobyte of flash memory, or 4 kilobytes of flash memory, excuse me. And then we clear the timer again for the watchdog timer and reprotect the memory. And here's another breakpoint you can set just to see it. And once we do that 32 times and program 128 kilobytes of memory, we will exit this for loop and turn the green LED on, wait 1 second, and while we're doing that we'll clear the timer just so we don't time out, and then turn the green LED off. And then we will loop back into the main while one loop and keep doing this over and over again until we get an interrupt or power is cut. So one thing to notice is down here you can see our memory allocation for main is about 7,076 bytes, and so I just want to show you how this looks once we optimize a little bit. So we go to project properties, and this is the properties window that pops up. Should probably be on general for default. You want to go down to build MSP432 compiler optimization, and on here you can change the optimization settings. I'm going to change the optimization level to about 3 inner procedure optimizations, and we'll see what that does to optimize the code. And so once we did that, we're going to go ahead and rebuild the code. And as you can see, the main memory went down from 7,000 to about 6,500 bytes. So that just shows you that the compiler went ahead and optimized our code a little bit and made it smaller. So we're going to go ahead and run this, and as you can see over here with the actual MSP430, it's been running this entire time because it's been connected to the computer, and so you might actually see the functionality working. I'm going to go ahead and re-download the code just to show you that it works with the code that I've presented to you. So we're downloading now. Loading the program to the device. And we're here waiting in main. So I'm gonna go ahead and run it just to show you the functionality at first. So I'll just hit run, and basically it's running through. It's currently programming the flash memory, and it should do that for about a minute, and then it'll be done, and we'll flash a green LED. So we'll just sit here and wait for that to happen. It'll be about a minute, and oh, there it goes. So you can go back in the video to when we started debugging and make sure that's a minute, but it should be about a minute. So this is switch 1 right here. If I press this, it should do the switch 1 interrupt, which basically stalls a processor and keeps relooping into that, so that it'll wait for the watchdog to time out, and then the watchdog will take over and reset the system. And you'll also see the red LED come on for about a second. So I'm going to press it. As you can see, a little blip was the red LED. It's not very bright, but you can also hold this down and set the interrupt off as well by holding it down or just pressing it once. And each time you do that, reset the system. So from right after the red LED goes off, it'll be about a minute for the flash to program. So now this is programming, I'm going to go ahead and set some breakpoints in here just to show you what's going on in the memory and show you that it is actually working and programming. So let me go down to this and set a breakpoint at no operation, and it should hit that. Yeah, there we go. I'm gonna go ahead and set one down here to check the memory, and then another one down here just to show you the memory after it's been, nope, not there, right here. Okay, so what we can do is we can go to our memory browser, and if you don't have that, you can go up to view memory browsers right here, and we're going to put the location, the beginning location of the memory in, which I put in the comment here, is it starts the bank 2 of the flash, which we're programming to, starts at this memory address. So I'm just going to put this over here and press enter, and we will see what the value of the memory is there. So as you can see, it is B0, B0, and it's all programmed for B0, and that corresponds to the data we put in memset, which was B0 plus I. So for the 0th iteration, it'll be B0. For the first iteration, it'll be B1, etc., incrementing on the hexadecimal scale. So it'll go up to BFF, or BF, and then it'll go up to C0. So as you can see, before this, it's all FF, which is just regular erase flash. This has been programmed for B0. We can go down, look at where it turns to B1. That's the next iteration. B2, and we can see that each of these iterations are, we can see where they end. The next memory location is hex 22,000, and so about 1,000 in hex is 4 kilobytes. So we can see that this is correct, and we're programming the right amount of memory. And if we just keep going down, we can see B4, B5, B6, exactly how much we have programmed so far. B7, B8, BC, BD, BE, C, and yeah, so you can definitely see that all this memory has been written to already. And if we look at where the I is right now, it's at 12, so we should be at, actually back up here to be... Actually, we can look in here. We can see 12. We're going to go to 2B. So 2BB. Probably BC. Nope. Maybe BF. Yeah, here it is. Okay, so BD after BD, because we're in the 12th iteration, when it goes to BE, we just erased that flash, so we can watch this as we change it. And so we're going to move on from the breakpoint and continue the program. So now we are, we just erased the flash sector. We're going to program the flash sector. So you should see these values changing. There we go. Yep, there's BD being written. You can see it's in red. And we'll keep running and run to the next one. And it's set. So, yes, you can see the flash memory changing. You saw the program running, and I'm just going to go ahead and quit debugging so you can see that the program still runs on here without the debug mode going, and you can see the interrupt still responsive. And I'll leave it here so you can observe that this green LED does in fact turn on again. But other than that, it's pretty much the entire project. Yep, I think that's pretty much all I have to tell you about it. If you have any questions, let me know. And thank you for watching. And I'll just leave this here until the green LED comes on, just to say it still works. Thank you. Alright, there we go. Thank you for watching.